This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. A continuous load path is not a pile of strong parts. It is an unbroken handoff from one structural part to the next, all the way to the foundation. That is the central idea I want you to keep. A heavy shear panel, a large hold down, and a strong concrete footing do not rescue a missing connection between them. The system is only continuous when every handoff is present, correctly located, correctly fastened, and installed as the approved plans require. Imagine a contractor looking at a framed wall that appears exceptionally solid. The sheathing is on, the studs are straight, and the foundation is substantial. One specified connector at the floor line is missing. Gravity may still travel downward through the wall, so the building can look normal under everyday weight. Lateral force is different. During shaking, that missing connector can become the point where force stops transferring into the next part of the system. The visible strength around the gap does not close the gap. That is why the general B role is not to redesign the lateral system in the field. My job as a supervising contractor is to recognize the intended path, coordinate the work, compare the installation with the approved plans, and stop an unapproved change before it becomes concealed. Official preparation resources identify seismic hardware requirements and installation as a key area. The practical skill is inspection readiness and defect recognition, not structural engineering calculations. Gravity and lateral force can use the same building, but they do not ask the same thing from it. Gravity acts mainly downward. Roof weight moves into rafters or trusses, then into walls or beams, then into lower supports and the foundation. Properly sized wood framing handles that downward compression efficiently. Lateral force acts sideways. Earthquake motion accelerates the ground while the mass of the roof and upper floors resists that movement. The structure can try to rack out of square, slide along the foundation, or rotate and lift at one end. The lateral system has to collect that sideways force, move it through horizontal diaphragms, deliver it into vertical braced wall panels or engineered shear walls, and anchor it into the foundation. Looking at this comparison, I separate the two paths by direction, resisting action, and the field question I need to answer. For gravity, I ask whether the bearing members provide a continuous downward support path. For lateral force, I ask whether every mechanical connection transfers shear or uplift into the next designated element. A wall can be excellent at the first job and incomplete at the second. The roof or floor sheathing can act as a diaphragm. In plain contractor language, that broad horizontal surface gathers force from a large area. The diaphragm then has to hand that force to the vertical lateral system. Once the force reaches a braced wall panel or shear wall, the sheathing and its approved fastening pattern help keep the framed rectangle from racking. At the bottom, two different actions matter. Sliding force tries to move the wall sideways across the foundation. Sill plate anchor bolts provide the foundation connection that resists that movement. Overturning tries to lift one end of the wall as the opposite end presses down. Hold downs or tension connections resist that uplift where the approved design requires them. I do not treat an anchor bolt and a hold down as interchangeable simply because both touch concrete. They address different actions within the same path. The California Residential Code states the controlling requirement in section R301.1. The building must provide a complete load path that transfers loads from their point of origin to the foundation. I remember that sentence as a handoff rule. Every collector, panel, strap, connector, bolt, and foundation attachment has to pass the force forward. The sill plate connection is the last wood-to-concrete handoff in a typical wood frame path, and the baseline anchor bolt numbers are worth knowing exactly. California Residential Code Section R 403.1.6 provides the statewide residential baseline addressed in this lesson. The reference begins with a minimum anchor bolt diameter of 1/2 inch. The bolt must extend at least 7 inches into concrete or into a grouted masonry cell. Along the sill plate, bolt spacing cannot exceed 6 feet on center. Each individual sill plate section needs at least 2 anchor bolts, even when the section is short. The end distance rules work together. A bolt must be no more than 12 inches from each end of the plate section, but it also must be no closer than 7 bolt diameters from the end. One rule prevents the end from being left beyond the required anchorage zone. The other preserves enough wood beyond the bolt to resist splitting at the end grain. For a 1/2 inch bolt, 7 bolt diameters equals 3 1/2 inches. I multiply 1/2 inch by 7. That means the bolt cannot be closer than 3 1/2 inches from the end, while the same bolt also cannot be farther than 12 inches from that end. Those limits are not competing answers. They create the permitted end zone. Consider a hypothetical foundation where a wet set 1/2 inch bolt lands 2 inches from the planned end of a sill plate. The bolt is present and the plate can be drilled over it, but the location does not satisfy the 7 diameter minimum. Under lateral loading, the fixed steel bolt can bear against a very small amount of wood at the end, creating a splitting risk. The correct supervision response is not to ignore it because the nut fits. I flag the condition before concealment and obtain an approved correction from the responsible design and building authorities. The same discipline applies to spacing. 6 feet on center is a maximum, not a target, that allows an extra inch for convenience. The 2 bolt minimum applies to each separate plate section, so a short cutoff does not automatically qualify for 1 bolt. Embedment is also a real installation condition, not merely the length of thread visible above the plate. I verify the anchor installation before concrete placement, when possible, then verify the actual sill connection during framing. This is where sequencing protects the schedule. Catching a misplaced wet set bolt while layout and concrete work are still open gives the project more options. Discovering it after drilling the sill, standing the wall, installing finishes, and covering the connection turns a small layout error into demolition, engineering review, and delay. I treat anchor layout as part of the structural path, not as a concrete detail that belongs to someone else. The general 1/2 inch baseline does not mean every condition uses the same hardware. In Seismic Design Category E, California Building Code, Section 2308.3.1.2 increases requirements for the braced wall line sill plates covered by that provision. The first distinction on this chart is the bolt diameter. At those Seismic Design Category E braced wall lines, the minimum is 5/8 of an inch. I keep the condition attached to the number. I do not turn 5/8 of an inch into a blanket rule for every sill plate in California. The same high seismic provision calls for heavy plate washers in the specified applications. The minimum plate washer is 0.229 inch thick and 3 inches by 3 inches. That larger bearing area spreads the connection force across more wood than a small round washer. Under demanding lateral loading, concentrated steel bearing can crush wood fibers around a small washer. The plate washer reduces that concentration by distributing the load over a wider area. A diagonally slotted hole in that plate washer can be allowed under the cited provision when a standard cut washer is placed between the plate washer and the nut. That intermediate washer gives the nut a proper bearing surface instead of allowing it to bear directly over the slot. The detail matters because a large plate washer does not perform as intended when the nut bears poorly at the opening. I also keep the code brand neutral. A familiar manufacturer name on the box does not replace the approved schedule, and a different brand is not automatically forbidden, merely because it is different. The controlling questions are whether the exact product and installation are approved for the project, whether the specified fasteners and capacities match the design, and whether any change has received formal approval. Visual similarity is not an engineering determination. The load path can still be broken above the foundation even when every anchor bolt is perfect. California Residential Code Section R 502.2.1 requires a specific lateral force path between horizontal floor framing and vertical braced wall panels. The force gathered by the floor cannot simply arrive near the wall. A connection has to transfer it into the wall. Think of a floor diaphragm as a broad surface collecting a sideways push. The force spreads through the sheathing, then has to be gathered at supported panel edges and delivered into the designated vertical elements. Blocking, framing connections, and the approved fastening schedule create that handoff. If the floor is stiff but the edge connection is incomplete, the force has no reliable route into the wall below. Section R502.2.2 addresses subflooring that serves as a horizontal diaphragm. The panel edges must be blocked, and the blocking must use utility-grade lumber or better. The practical point is that adjoining panel edges need continuous support so the diaphragm can act as a connected surface rather than as separate sheets moving independently. I do not memorize a universal nail size or spacing for every shear condition, because the research for this lesson does not support one statewide schedule that fits every engineered design. I verify the edge and field fastening against the approved plans and the applicable schedule. A crew habit, a remembered detail from another project, or the nails already loaded in a gun do not override the project documents. Suppose a crew installs an engineered vertical frame at an open first-story line but uses ordinary framing connections, where the plans specify a higher capacity transfer connection from the floor diaphragm. The frame may be anchored beautifully to the foundation, yet the upper floor force still lacks the approved handoff into that frame. The expensive lower element cannot resist force that never reaches it. That is the weakest link principle in field form. At each floor and roof line, I ask 3 questions. What element collects the lateral force? What exact connection transfers it? What element receives it next? Those questions keep me focused on the joints between systems, where coordination errors are easiest to conceal and hardest to correct later. Approved plans set the general B boundary, California Administrative Code, Section 4-3. 4.3, subsection A, supports the duty to complete the work in accordance with approved plans. For seismic hardware, that means I do not substitute a connector, change a fastener schedule, relocate a hold down, or alter a structural dimension based only on field judgment. Imagine a crew that runs short of the specified hold down and finds another product that appears to fit the same anchor. The schedule pressure is real, but appearance is not approval. Different connectors can rely on different fasteners, steel properties, geometry, tested capacities, and installation conditions. Installing the substitute first and asking for forgiveness later puts concealed work ahead of design review. The proper sequence is to stop work on the affected assembly, document the availability problem, and request formal approval from the architect or engineer of record through the required project change process. Where a construction change document is required, that document must be handled before the alternate becomes accepted work, along with any required building department acceptance. I keep the original specified installation in place unless and until the change is approved. That same rule applies to fasteners. A connector with empty required holes, the wrong fastener type, or a modified hole pattern is not fully installed merely because the metal is present. I compare the hardware identification, location, orientation, fastener type, fastener count, and attachment to the approved detail. I also make sure the connection remains visible for the required inspection before covering it. The contractor's value is judgment about when not to improvise. A non-structural convenience change and a seismic load path change are not the same category of decision. When a proposed change touches the root that transfers shear or uplift to the foundation, I treat it as a design-controlled item. I use a top-to-bottom inspection habit because it mirrors the direction of the handoffs. I start at the roof or floor diaphragm shown on the plans. I verify that the sheathing, blocking, boundary framing, and specified connections create the intended transfer into the vertical wall system. Then I follow the wall to its base, checking the panel fastening, specified wall framing, hold-down locations, sill attachment, and foundation anchorage. I do not let a large piece of hardware distract me from small required fasteners. The most impressive hold-down on the project cannot compensate for missing diaphragm edge fastening above it. In the same way, perfect diaphragm nailing cannot compensate for an anchor bolt that lacks required embedment or sits outside the permitted end distance. Each link has one job, and the path depends on all of them. For sill anchors, I run the number check without mixing minimums and maximums. Minimum 1/2 inch diameter for the baseline condition. Minimum 7 inches of embedment, maximum 6 feet on center. Minimum 2 bolts per plate section. Maximum 12 inches from each end. Minimum 7 bolt diameters from the end. In the specified seismic design category E braced wall condition, I shift to the 5/8 inch minimum and the required heavy plate washer detail. For diaphragm transfer, I check that the horizontal framing has the specified connection to the vertical braced wall panels. When subflooring serves as the diaphragm under the cited provision, I check blocked panel edges and utility-grade lumber, or better for that blocking. Then I verify the project-specific fastening rather than importing a schedule from memory. For hardware changes, I use a simple stop point, no field-declared equivalent. I compare the approved documents, identify the discrepancy, keep the work open, and route the change to the responsible design professional and authority. That habit protects the load path, the inspection, and the contractor's administrative responsibility at the same time. This is a testable concept based on the CSLB study guide, but it is also a practical supervision method. Follow the force, inspect every handoff, and refuse to guess at a structural substitution. The continuous load path is a chain, and the contractor's inspection is strongest at the joints. I want you to practice this material while the distinctions are still fresh, so I made an audio practice quiz, specifically for this episode on the continuous load path and shear transfer. It is audio-based. The questions are read aloud, and you answer by tapping. I designed it for people studying while driving, working, or moving between jobs, because I know study time often has to fit into the day you already have. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about the load path, anchor bolt limits, plate washers, diaphragm transfer, or approved substitutions. I read those questions as signals about where another explanation may help. Subscribe so I can keep you on track through every episode until you get your license.